So as we were talking about, when I do this box, I get both a max and a min included in this graph. To kind of label those out for us, our max and our min. Now, the reason this is important is because it helps us design how long it takes for this graph to repeat itself, which is, in essence, the period. How long does it take before this graph goes through one full cycle or eventually repeats itself? Which means, if you really think about it, it starts at 0, 0. I have a max, a min, and then I get back to 0, 0. And then once again over here, if you notice, I start with my max again. So that shows me within that box, I have one full repetition of sine. Well, if I start from 0 and go to 2 pi, every 2 pi has to be a period. And the reason that's a key number for us is because if we do our conversion, 2 pi is the same as 360 degrees, which is one full rotation around the circle. So as you kind of can see, it literally just is graphing the points from the circle. You literally graph all your y coordinates around the circle. You go all the way around, you graph all of these coordinates out, and then you get back to 0, and then you do it again. And that's kind of how this graph works. It's just a repeating of the circle over and over and over again. Okay? Now, obviously, we have to go a little bit more in depth. That's kind of the basic idea of sine. Now, as we move forward, we really want to start to understand how do we really apply this. On that first page, I had an equation written, which is y equals a sine b of x, which is going to be kind of our next step. We want to start looking at how do these values affect my sine graph. And the first one we're going to look at is just a. Now, if we were to plug this in the calculator, let's say we graph out this function, y equals 3 sine of x, okay? A lot of it's going to be very similar in the fact that I'm still going to have a starting point at 0, 0, and I'm still going to have an ending point at 2 pi. Okay, it's still going to be one full revolution. On top of that, I'm still going to have a value of 0 at pi. Where it changes is if you really think about what's going to happen at some of these coordinates. Let's say I were to plug in this coordinate right here, pi over 2. Y equals 3 sine of pi over 2. Well, if I think about just this piece of the problem right now, sine of pi over 2. If I were to go back to my unit circle, pi over 2, which is just 90 degrees, is just an answer of 1. So technically, sine of pi over 2 is just 1. Well, that would mean all I have to do to solve this problem out is just take y and do 3 times 1, which is just 3. So if you notice, instead of having a coordinate of 1, similar to this graph right here, where at pi over 2, I have a coordinate of 1. Now it almost stretches and gives me a coordinate of 3. And you can probably guess over here at 3 over 2, it's just going to go down to negative 3, giving me a graph that looks like this. Up, down to our min, back to the beginning. This number, or this value of 3, directly relates to a specific part of the graph. While in this graph we had an amplitude of 1, this graph is going to slightly change. Now, because of this value in front, my amplitude is now 3. So we can automatically assume that this a value is just my amplitude. Okay? And it's an easy way to actually solve a lot of these out. If I were to go down to the bottom of this page and talk about this problem, where they want us to find the period, the amplitude, and the midline, well, the really only thing that I see in here that's different is this. I have a 2 in front. So my amplitude is just 2. My period hasn't changed. We got to think, what's one full rotation around the circle? Well, it's 2 pi, or it's going to be 360 degrees. And the midline hasn't changed either. It's just y equals 0. So now we can kind of adjust these equations based on the value in front. Remember, that value of a in front is